Hello and welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 11.2 on data analysis and displays, in which we ask the essential question, how can you use a box and whisker plot to describe a data set? So maybe this caught your eye here. What's a box and whisker plot, Mr. Takeda? Well, let's tell you. A box and whisker plot. Basically, the box and whisker plot is this picture down here. It's above a number line. Now they don't have numbers on this number line because it's kind of a generic picture, but the numbers refer to the values on the picture, on the box and whisker plot. See, there's a box and there's the whiskers out here. It looks like a little square cat, doesn't it? Okay, so what are the values here? Least value, this is the smallest value in our data set. Now, way at the other end of the whisker, there's something called the greatest value. Now, sometimes you'll see these drawn with X's instead of dots, and that's okay too. Now the box here, it starts at what we call the first quartile, Q1. The median, which we've already talked about, is here in this line. Now you notice it's not right in the middle of the box necessarily. And then the third quartile is the end of the box over here. The idea is that there's an equal amount of data in each of these four parts. So this little box contains this little part of the box contains as much data as this part of the box, which means what? It means this part of the data is all spread out. This is all kind of close together. Okay, let's talk. We know what least value is. We know what median is. We know what greatest value is. Let's talk about third quartile and first quartile. These quartiles are essentially the medians of each half. So since half of the data is on the left of the median, the first quartile is the median of this half. The third quartile is the median of the upper half. Okay, so these five numbers we put together to call the five-number summary: least, first quartile, median, third quartile, and greatest value. On the we're going to make a box and whisker plot here to represent the ages of the members of a backpacking expedition in the mountains. I'm going to do it manually here. You've already watched, hopefully, a little video that I made last year that shows how to use Desmos to come up with these values. Okay, so you can do it that way. I'm going to do it the hard way just for this video, but you can use Desmos to come up with these values. Since the first thing we need to do is come up with min, max, and median, we need to put these in ascending order. So I'm going to do that right now. Alakazam. There they are. So I put them in order, and we know the first thing we're going to find here is the median. And since I have 12 data points, my median is going to have 6 on the left. So 1, 2, 3, 4, 5, 6. So the median is right here. So my median is the mean of these 2 points, 25 and 25. So that's pretty easy. The median here is 25. Before we get too far, let's set up our number line here, so we can start our box and whisker plot. Let's see. I'm going to make. I think I'm going to do this with 10. This is 20. 1, 2, 3, 4. This would be 30. Okay. One thing about the box and whisker plot, you kind of have to give yourself some room, especially with these numbers because they're pretty close together. Okay. So our median here is at 25. So I mean, again, the box and whisker plot is above the number line. Okay. So 25. And let's find that Q1. I'll make Q3. Q1, since I have 6 data points down here on the lower half, I'm going to have 3 above and 3 above my quartile. So it's going to split it there. But the average of 22 and 24 is going to be 23. I said the average. I mean, it's a mean of 22 and 24 is 23. And up here, right there, between 28 and 29, it's going to 28 and 30, it's going to be 29. Okay, so let's go ahead and put those in. There's 25, this would be 22 and a half, so 23 is about here. That's my Q1. 29 is going to be up here, and that makes our box. Okay, and then it's just a matter of coming up with a lower at 18. So 18 is going to be about here, like in the X. 30 is real close up here. And then we connect those with whiskers. That's it. That's our box and whisker plot. Again, the idea is that each of these sections have the same amount of data. So in between here and 30, we have 3 pieces of data in here. I've got 3 pieces of data in here, right? 3 in here, 3 pieces of data in here, 3 pieces of data in here. Okay. So what does that kind of mean? Well, that kind of means that if you look up here, we've got some older people, more older people than younger people, because this 18-year-old kind of stretches out this this whisker down here, right? Otherwise, we'd be way up in here somewhere, a shorter whisker, if it wasn't for him being so young. Okay. And the 25, 27, 28, they're more spread out than 24, 25, and 25. Right? Okay, so that's our box and whisker plot. And now let's talk about shapes of box and whisker plots. Skewed left, and what's happening here is, again, there's more data in the left whisker is longer than the right whisker, so we call this skewed left, but because most of the data is on the right side, because it's shorter, right? These little sections are smaller, so there's more data in a smaller area. Symmetric means it's roughly even. The whiskers are about the same length, and these 2 sections are about the same size. Skewed right means we have a longer right whisker than left whiskers, because most of the data is on the left side. We have more data crammed into this part than this part. There's our median. Okay. All right, so let's take a look here. Find and interpret the range of the data. So our range, we know, is going to be the biggest data point, 300, minus the smallest data point, 160. So 300 minus 160 is going to be 140. So our range is 140. And it says to interpret the range. So the box and whisker plot here represents the length in seconds of the songs played by a rock band at a concert. So the song lengths vary by no more than 140 seconds. So the long songs are 300 seconds, the short songs are only 160 seconds, so they vary by 140 seconds. The distribution of the data, each whisker represents, again, each part of this represents 25%, but because this is longer down here, right, we call that skewed left. Most of the songs are up in this area. We call this skewed left. If you want to get into it, you can say 25% are between 160 and 220, 25% between 220 and 260, 25% between 260 and 280, and 25% between 280 and 300 seconds. Interquartile range. Now, this is something we haven't talked about yet, so I want to make sure you understand interquartile range. And we call this the IQR. And what this is, it's the difference between Q3 and Q1. Okay? So in this case, it's 280 minus 220. So we have an interquartile range of 60 seconds. This means that the middle half of the song lengths vary by no more than 60 seconds. We're talking about middle half. We're talking about the middle 50%. They are going to vary by 60 seconds. Are the data more spread out below quarter 1 or above quarter 3? So we're talking about the whiskers here. And of course, they're more spread out below quarter 1 because we have a longer whisker. Okay. And that's it for now. Again, the video that you previously watched kind of shows how to come up with those values, those 5 values using Desmos. And it doesn't create the graph for you, this kind of graph for you, this kind of data plot for you. You have to do that on your own, but you don't have to do it manually. You can put the data in, and it'll calculate it all for you. That's it. Have a great day. I know this is a rerun picture, but I can't search on Google to find new pictures. Thanks. Bye.